Good afternoon. My name is Catherine, and I hope so everyone is hearing me. If someone can give me a thumbs up on a chat that you can hear me clearly, that will be very helpful. One more time, we starting today topic is evening before paper to higher physics from AQA. I hope so you are all well and you hear me good. I do not expect if anything it's not going right, please just drop message on the chat and we will fix that. So I prepared today for you higher tier physics paper 2 high mark questions. I have 4 of them that very often appear. Maybe that will not be at the same topic, but the same requirements will be needed to score the highest number. So we will start from question number 1 from the past papers, which required knowledge about scientific approach and how to perform experiments and how to describe methods. So question 1 said that student is investigating how the current in the filament lamp varies with the potential difference across the filament lamp. So we have figure below that show us the results. We have current in amps on the y-axis and potential different in volts on the x-axis. What is important when you approach paper 2 physics higher tier is to make sure that you read questions carefully and you know exactly what are the requirements, what the exam body asks you for. So in this case, they just gave us graph. You can see that we have positive and negative values of potential difference. That is important because each time when you measure potential difference, you will have results as a positive or on as a negative if you're connecting your components incorrectly. So the first question is to describe methods the students could use to obtain those results that are shown on the graph above. And maybe not significantly pop up, but they ask to include the circuit diagram. From my experience, the most important what you can do for yourself is to highlight or underline what exam body, what question actually ask you. So first thing what is important, they ask you to describe a method. So they ask about step-by-step description. The best and the easiest will do that in bullet points, and to score the highest number of points for 8, which in this case will be 6 points, the requirement is you need to think the way that if someone will read your instruction, your step-by-step, will be able to recreate the experiment that you see, those results. That is very important because every time when you miss some step, you will lose the mark in description. So if your step will be including just that you need ammeter and voltmeter to measure the current and potential difference, as well as filament lamp, but you will not give information about what the range needs to be measured in or what the steps it's required to measure, you will lose the points. So you need combine here, and that's the tricky point in higher tier of physics. It's that you can comprehend between what you see and what the question asks you to do. The other thing in that question, apart of describe the method, is include a circuit diagram. You will not be able to score 6 or 5 points if the diagram will not be included. So let's start from what it's required to assemble, to measure what we need. We measure currents, so first thing what we will need is ammeter. And hopefully I know that you folks are clever brains on the other side. Ammeter in our circuit will be always connected in series. In series towards what? We want to measure current of the filament lamp, so it needs to be connected after filament lamp and in series with filament lamp. So that will be your first step. Second, we know that to measure potential difference, you will need the separate device, which is voltmeter. Voltmeter, to measure potential difference, it's required to be connected in parallel around the device that you want to measure potential difference at the start and at the end, which in our case it's filament lamp. Ammeter. If you did not describe that at first, what ammeter is measure, you can describe that into the next point. The most important part is to not assume that the person who will check your paper, your answer, will know what you have in mind. Okay, so you need to remember that in higher tier, you need to make sure that all your thoughts need to be written down on paper. So ammeter will be used to measure current, and voltmeter to the potential difference. Important, potential difference, the name of potential difference, it's very important. AQA required, opposite to some other exam boards use potential difference. Please don't use, I will highlight that in a second, please don't use voltage. Voltage, it's a word used in engineering usually. It's technical word. AQA required to use potential difference in every single time when you're talking about measure the difference between voltage entering the component and leaving it. What else? We will need filament lamp. I will start from the beginning. 5. Filament lamp and how to change current, what I need to use. In this case, we will use variable resistor. which will be used to vary the current. And that will vary the current and potential different PD as a short name to potential different. If you state that one times, you can use the short name, but I will highly recommend to just write down the full sentence, full words. It's just to be on the safe side. Across filament lamp. Okay, so that is what I need to make sure that I can build my circuit. So I'm starting from battery. I see that the voltage is quite low, so I can use 9-volt battery. If you decide to use power supply, that's okay. Just to draw the diagram, which I'll do my best to do that the quickest I can. That's the point, and that's they required you to draw the diagrams, schematic circuit, because they check your knowledge about the symbols. Okay, so all what they demand, it's not just because they won't make your life more difficult, it's because they would like to see that you understand in depth what you will be doing and what you will be measuring. So we have my battery that will be connected into my variable resistor. Variable resistor, the different is in symbol that you drawing the arrow that suggests that you can change the current and potential difference changing resistance. After that, we need connecting our filament lamp, which the symbol is circle with X. They tricked you. They may trick you. They may say that there is LED lamp. You need to remember that LED has different symbol than filament lamp. Filament lamp is the circle with the cross. The diode is a triangle with the line at the back. Okay, so please make sure that you are reading accurately what actually your setup include. And as we state, to measure the current, I will need to connect the ammeter in series, so one after another after filament lamp, and I'm back to my battery. It's good to use and mark that you understand what are the where is the positive and negative side of the battery. Positive is always longer side of battery. What I need to include here, my state that I will measure current, just marking A inside that tells information that that is ammeter. So my electrons will leave the battery, depends from the variable resistors, will brighten the lamp with higher brightness or lower. We can then measure the current, depends from the resistance back. Another thing that we will need to require to pin into our schematic circuit is voltmeter. We say that it's connected parallel with filament lamp. So I will take, I highly recommend to do that outside of the circuit, but if you will draw that inside, that's not that big deal. As soon as you connecting them accurately, so in parallel instead of in series. Okay, voltage. Solid line, so I need surround my filament lamp, my bulb, because I would like to see what is the difference in reading at the start, at the entering of filament lamp, and after. Okay, so that is circuit diagram that will be working one. Obviously, if you make any mistakes in it, you will lose some points, but to obtain that curve, you need to regulate potential difference, reading current, and reading potential difference from voltmeters. So what are the next steps? So we state what components we need and what elements we need to measure potential difference and current. What else we need to state in my method to make sure that I will get exactly that curve. So the next point will be what is the range. So as you can see from the diagram, if that is the connection, you will measure always, you will have positive value of current and positive value of potential different. So the range is from 0 to 6 volt. So you need to write down that the range of potential difference is between 0 and 0 volts and 6 volts. Okay, we will get to the point how to do that we have negative values. What is the steps? So you need to focus on where are my marking points, where are my data drops. Data drops are marked by small x's. We can easily testify and justify that they are every 1 volt. So that is very important to include in my method, because someone who would like to recreate your curve needs to know how often measurements need to be taken. So the intervals or steps of 1 volt. Remember about use the units. It's very important, especially in a higher paper, that it's just justification that you understand what you are doing. Okay, what to do? So in this case, in such connection of my components, I will just get the positive side of my graph. What to do to measure the negative side? It's very simple solution for that. It's just swap my battery another way around. Let's choose some other color if I can. There we go. Sorry. Oh, there you go. Move in a second. There you go. And that is my last point, that reverse connection of battery or power supply, if you decide to use power supply in your method, will by reversing power supply, we will obtain negative results of results. Sorry for that. Results of potential different and current. What else we need to do? As a professional scientist and in higher paper, they will require you to include scientific methods, how you're doing this. It's one measurement, it's not always enough. You need obtain and take and repeat your measurements several times and take mean from it. Okay, but it's important because that leading us into situation when we need to remember that because that it's live experiment that you will perform, you will need to exclude any anomalies. I'll write them here. Okay. Why it's important to say that? Because when you look at that graph, you do not have any points that are much different or are standing out of the curve that you see. So that's it. That's that description with including the circuit diagram will gives you full marks of 6 points. Okay, that is it, and I believe in you that you absolutely are able to do that. The only thing, please remember when you will doing that, it's to read and carefully check if every single step it's written that person who would like to repeat your experiment will easily be able to recreate after reading what you've done. Okay. Next question that next point of that question, it's the calculation that it's 2-point questions. It's very important when you see the number of points that you can get, it's to testify and justify how much work you need to put into it, how many facts the person who will check that those your answer will be able to find. So determine the resistance of the filament lamp when the potential difference across it is plus 3 volts. Use the physical equation sheet and use the figure above. So they refer to the figures from the diagram. We have that they ask us about determine the resistance, which I know what I need to find. My R, it's this what I'm looking for. I have information of potential difference that it equals 3 volts. Now, missing is my current, but they ask you to use the figures from above. So what you need to do at that point is to go to diagram and check what is the value of current for 3 volts. So I can zoom in a little bit so we can clearly see 3 volts. You can use the lines to make sure that you're reading correct value of the current. So that's my 3 volts. That's the point. How to testify how much is it. We have 5 spaces, those small squares between the bold lines. It means that every single line is 0.01. In my case, my current is 0.016 amps, and that it's important to use units. Remember, it's higher tier, they will look at your understanding of physics. So we say that is 0.16 amps. Remember, capital and small letters in physics are very crucial. if you will write down the small letter A or small letter V, it will give your examiner doubts that you know the units. So we have read and pid. If you remember, our equation for calculating resistance is current times potential difference. Potential difference, what I'm saying. Sorry for that. So you did not have that. Vir not rip, which will be potential difference. It's equal to my resistance time current. Values that I do have from my equation, just to remind, I have potential difference, I have current, so I need resistance, which will be, I will try to draw. If I divide by I, by the current, both sides of the equation, I will have that my R, it's equal potential difference divide by current. Okay, so either if you will write down equation for potential difference or already transform to calculate the resistance, that will be 1 point in that case. And what we have, my potential difference was that it's equal 3 volts. At that stage, don't need to use units, divide by 0.16. That gives me value of resistance, if I calculate that, okay, 18.75. In such case, there is room for your decision what answer you would like to do, but if in that case you can either go to 18.8 or everything to 19 ohms will be correct. Okay, so either you will write down to 2 places after decimal or 1 or to 2 significant numbers, that all will be good. Okay, the next point in that question is we have current in the lamp, it's 0.21 amps. I like always to highlight what are the significant information in my question, and that current appears when the potential difference across the lamp is 6 volts. Calculate the energy transfer by the filament lamp in 30 minutes. Oh, that's the first thing what they will try to check if you understand how to go to standardized units. Our 30 minutes is equal to 1800 seconds. Okay, second is our SI units, so that will be 1 point here. It will be 1 point. So it's worth to remember to write down everything what you are doing, because all those small significant steps will give you points. Energy transferred. Energy transferred, it's how much energy will be transferred through your filament lamp within that 30 minutes. So we can either go from equation from describing the current times time, or you can choose to calculate that from power, which power will be equal to pure current times voltage. Okay, it's important to write down the equation that you will use, They ask you to take them from equation sheets, so you don't need to remember them. You just need to remember and know how to get from information they will give us to calculate energy that was transferred. So I will do both sides. In the case of left side, my Q, I have all information I need. It's 0.21 times 1800. Important information for you, even if you at that stage make calculating mistake, but your calculation will have logical way of doing it, you will carry on achieving your points. So it's important to carry on with your calculation, which is 378. And from that, I can calculate that my energy transfer is equal to how many electrons were flow times potential difference, which is E equal 370 times my potential difference as above I mark, so that takes distraction from me. It's 6 volt, and that is equal to 2268 joules. Okay, so that's the answer here. Let's check if calculating that from the power will give us the same results. So the first step to calculate that from the power, it's P equals 0.21 amps times 6 volt, which gives you 126, and the second P equals 126, and because it's power, we express that in watts, which gives us energy transferred will be equal P times T, so power transferred in given time, which gives us 126 times 1800, and that giving us exactly the same results. Which method you choose doesn't matter. Remember to write down the equation that you start from, equation that you calculating energy transferred. If you make mistakes in the calculating process, that's okay, they will still give you points. Okay, so that's not big deal if the finger will slip on your calculator or you will just mistake 0 with 8. That's fine. Okay, going to the last bit, we have that the power output of the filament lamp is 1 watts when the potential difference across the lamp is 5V. So we have information of power and potential difference. Students predicts that the power output would be 4 watts if potential difference was doubled. Explain, oh, that's the very important keyword, why the student is not correct. So explanation will that point D, it's 3 mark question. You can achieve here 3 marks, so it means you will need to give the reason and explain that 3 different facts need to be stated in your answer to make sure that you can achieve the maximum points. So they basically saying that for power to quadruple the current and potential difference, you would both if you want power be quadruple, the current and potential difference needs rise double. So that's what students say. That's what students want to achieve. Why is that not correct? Because when the current doesn't double, and in our case, in our circuit diagram, when you look above, or you can calculate that, current doesn't double because the resistance of filament amps increase. It's not working like that. How you can testify that? When you look at the graph, the dependence from potential difference and current, it's not linear. So it not means that when I double my resistance, potential difference will double. It not means that current will go at the same rate up. So from at that point, that's the one thing that you can read and you can testify using your graph. Another thing is that even the current will double, the potential difference will not. So you can tackle that question, that assumption that student made from both sides. Current and potential difference are not in a linear relationship. It not means that when my potential difference increase, the same rate of increasing in the current will be observed. So how to write this down? So explain why it's not correcting. For power, to quadruple, the current and potential difference would both need double. That's the first statement. From the graph above, we can see that current does not double current does not double when potential different. Twice, that's the one way of explaining that, or the current doesn't double, the current doesn't double simply because the potential difference and that okay. If you will have any question to that, please drop on a chat and I'm more than happy to explain further that. So that is all for 12-mark questions. So a lot of depends from how you explain the first question, how well you understand what is given for you and how to perform the experiment. Okay, so the next set of questions that I choose for you is about the light. So question is marked as a 11-mark question in total. We have A, B, C, D, and E with required explanation. So light is usually described as a wave. We know that light is a wave, but also can be described as a stream of particles. There are two different scientific models. That's very important because scientific models will depends from how much information we have from how much and how good our understanding and knowledge is at the moment of creating scientific model. Okay, why that is important, we will back to that in a second, because one of the questions will ask us about that. So which statement describes the scientific model? Is a small scale version of a real object. It's a way of guessing. Guessing it's not, oh, it's no, huge no. In physics, we are not guess, we want to have proofs of what happened, and an idea used to explain observation and data. Scientific models, it's not just small representation of real model. Scientific models are used to explain observation in data. So that's what it will be. Let's mark this, okay? And that will heavily depend of how much observation do we have, how much access to those observations we have, what is the technology around that allowed us to observe and go deeper with understanding and making further observation, and how much data we collect, how accurate that data are, and how our knowledge and knowledge that is accessible will explain those data. That's why scientific models across the years change, and that's why we have better and better understanding of what actually it's happening that we observe. So the first question was on why the scientists sometimes have different models, like the waves and particles models of light. So they gave you suggestions here what you should refer to the model that was described above. Why we say that different models may be appropriate in a different situation. It's when we're talking about particle models, they may not be able to explain all observation. Sometimes the people who need that scientific models may not need detailed enough scientific model, because that will create misconception for them or misunderstanding. They just need general approach to the problem. So that will be depends from what situation it is and what is the appropriate to show in your model. Different model may be appropriate in different situation, or one particle model may not be able to explain everything, not be okay. So either of those will be absolutely okay to achieve here 1 point. You can choose, obviously, you all have very good brains. I bet both of you already done that beforehand. So question number C, it's sometimes an old scientific model, it's replaced by sometimes an old scientific model, it's replaced by new model. Keyword, explain. So they do not want you to just start what model and how it changed. They ask you to explain why. Why scientists replace an old scientific models with a new models. Include an example. One example, you don't need to go with a lot of example from physics in your answer. So, quick examples. Let's start from the backwards. You probably may think about periodical table and evolution of periodical table. We know that Mendeleev replaced the old model of periodical table and put all elements from periodical table according to the atomic weight. Why? Because he didn't see what is the system in the old periodical table, how that testify itself in the future by the ages, new elements were discovered and miraculously were fit to Mendeleev periodical table, and that's how other scientists were able to believe him that his model is more accurate than the old model. Another example is, oh, that will not be visible. Another example will be, for example, development of atoms. So nuclear replacement plum pudding model, yeah? Why? Because in plum pudding model, as we knew, the only information we had, they built on it that all elements are the spheres, they are positive spheres, then they discovered that they are elements of particles like electrons, but in plum pudding model they didn't know where they exactly are. They were thinking that they are like raisins in the cake, randomly placed within the atom. So by gaining more understanding and making more observation, more data were collected, they discovered that electrons in the atoms are actually placed around, and on a nucleus in the atom it's positive. And that's how plum pudding model was replaced by new nuclear model. And then by further experiments, they discovered that elements are placed on the shells. So they are circulated around the nucleus in very predictable way. So that's how the models replace the old models, because we have new informations. Explain why. Why? In this point, I will give explanation that new evidence may be unavailable. New evidences may be and give more and deeper understanding of problem. Or prediction used in old model can change and not fit anymore. So in this case, like with Mendeleev periodical table, he proved that previous old model and place of elements according to atomic number were not correct and were not accommodate the new discovered elements. So if that question is for 3 points, to explain reason and 1 example, that will score you the maximum points. Remember to clearly state between your example and explanation why, especially that they divide that in the question, so make sure that your description is clearly visible and clearly distinguish between explain reason why scientists replace the scientific old models with new, and what the example you give for that from physics. The next question is about some students use the water waves in a ripple tank to model the behavior of light waves. And you have figure one shows that what happens to the wave fronts. So it's that line, that's the wave front that's the wave front, the first line, as they pass the boundary between deep water and shallow water. So gray it's shallow water, and white it's deep water. Question is again explain. Explain means you giving the reason and you giving the explanation. What is your thoughts behind that? That need be stated very clearly and need include keywords and scientific knowledge. Explain why refraction happens at the boundaries between the deep water and shallower water. From optics and behavior of waves, we know that velocity or speed is slower in shallow water. That's the first statement. So speed in water is slower. So in this case, with that information given, with that knowledge having, so you show that you will use information about how waves speed or velocity depends from the medium that they spread around. Now you need to give how you will explain that. So we give the reason why, now explanation. So the edge of the wave, the front of the wave, entering the shallowing water will slow down. Of the wave entering water will slowing down. Just jump. No, I don't know why. Some information came on, I will ignore, but you know that the part of the wave that it's still in deep water will be faster. The part of the wave in the deeper end continuous at speed. So basically you describe what you see on the picture above. Yes, you just please don't assume that examiner know that. Those papers are checked by random people with absolutely high knowledge of physics, but they would like to see that you know how to explain, how to testify and explain why the refraction happens at the boundaries. So all those information that waves are slowing down in shallow water and continues at the higher speed in the deeper water, it's leading you to information and explanation why the boundaries, why refraction happens, because of the difference in speeds, leading to change in direction of the wavefront. So higher rate of speed of your wavefront in deep water, when it meeting the boundaries with the shadowing water, that speed stays in the higher rate. Waves slowing down in the shadow water, and that refraction happens because that part of your wavefront will slow down. And slowly the last explanation to the number E, and that will be the end of how to make sure that you meeting requirements. Remember, answering and not assuming that examinator will know what you had on your thoughts. We have now figure 2 shown that the wavefronts traveling parallel to the boundaries between deeper water and shadowing water. So again, higher rate of speed and slower rate of speed in shadow water explain again why the wavefronts in figure 2 do not refract at the boundaries. So we know that, I hope you know, that velocity is a vector. Vector has magnitude and direction. Yeah? So if the magnitudes of my wave will change on the boundaries, my wave, my speed, my velocity will slowing down and change the direction. If the boundaries is parallel to my wave front, that will not influence, because the only change that will happen in this case when boundaries it's parallel to wave front will be the change of magnitudes. So how to explain that? Every point on the wavefront in case of our figure 2 enters the shallow shallow water at the same time. And because of that, so every point slows down at the same time. Okay, so that do not cause the change in direction, because all points on your wavefront will feel the effect of shadow water at the same time, and all of them at the same time will slow down. So I know that you will be doing tomorrow absolutely marvelous. Please remember, read carefully the questions, look how many points it's for answering the question, and make sure that you can state and find in your answer 2 facts, 2 or 1 fact, an explanation. Don't go round and round. It will not give you points. So make sure when you're answering any calculating question to write down where the equation came from, or give already transform equation. Remember about the units. Remember about checking if the units are in SI standards. If not, please change them, because that will be the points. And I hope so that was useful, and if you have any questions, please drop them on the chat, and I'm more than happy to give you explanation. And good luck tomorrow. I keep my fingers crossed. I believe in your young curious brains. You've done your best through the whole past years, and do the best, and all will be fine. Okay, thank you so much for your attention, and have a lovely evening today. See ya.